Hello and welcome to another Solana tutorial. Today we're gonna optimize the program that we wrote last time, this profit checker, and then we're gonna learn something about rent. Because I'm just so curious about what happens if I have an account that I just used for one transaction, then I can throw it away again. Do I need to pay for rent? And in which circumstances do I not need to pay for rent? Those are the questions that I want answered today. So let's just get started optimizing a program and learning about rent. Okay, this is the program we wrote last time, a profit checker. Basically, we have one instruction that we call in the beginning of the transaction that just stores how many lamperts are on one account. And then we have one instruction that we call at the end of a transaction that actually checks if we made a profit by failing the transaction otherwise. We don't really need this part, and we also don't really check for the trader. I just forgot about that last time. Actually, I should have something in the check accounts. I should do something like has one trader, something like this, that the trader of the account is actually the same as the signer here. I just forgot that last time, but that's okay because we don't need that really. Anyway, so yeah, that was just my simple profit checker, but it's fairly inefficient in terms of compute usage and program size. Because if let's do one of those, maybe just a successful case where we win, I don't know, not much. There we go. We have success because we made a profit, but compute units consumed is 18K, which is not huge, but it's also not nothing. And if we have a look at it, the profit checker here takes 6.7K and then here 3.5. So that's roughly 10K compute units just for the profit checking. And the market simulation, granted, also has 7,500 compute units. We're not gonna optimize this program because that we certainly won't use in production. But the profit checker I do wanna improve. And improve mainly in terms of compute usage. I might throw away some features that I'm not really using here anyway, or that I don't consider important for my use case. Because it's always a trade-off between how much you compute and what you're doing functionally. Anchor uses that many compute units because it does a few checks. Also, it uses inefficient libraries and stuff, but also it's a bit inefficient. But we do get something for those compute units. The thing is, we don't need most of those things. That's the thing. And that's why I'm gonna write a Pinocchio program where I can choose what I need and which checks I really wanna do. Because really, I'm the one using it. If I'm using it wrong, then whatever. I'm just not gonna use it wrong. I can just optimize my program. For instance, I don't need to check for specific accounts with an account discriminator. I don't wanna go with seeds. That's all using compute. And for my use case, I want to have as little as possible. Why? Because then I can optimize for transaction fees. Then I can have higher transaction priority by paying a priority fee. But the priority fee depends on the compute units I request. And that, how many I need to request, depends on how many I'm actually gonna use. We're on DevNet here. I'm not actually doing priority fee here yet. But if we go to production, then I would have to probably for that to work. So especially if we use contested accounts in the actual trading part, you know, that thing that we just simulate here for now. So I really want to optimize this. Okay, but you understand what the program does, right? It just stores the lamperts and then later checks if the lamperts increased or decreased and fails the transaction or not, respectively. Okay, let's write a new program. Let's do a Pinocchio profit checker. Yeah, I don't know. PP checker. Naming stuff is always the hardest thing. Efficient profit checker. No, I don't know. Proficchio. Whatever. Just do something. And then I cargo init here ellip as I would, and then I add Pinocchio. And then we're gonna write a Pinocchio program like this. There you go. Okay, can I already build this? Nope, thought so. I thought so. There you go. Okay, now, so that's my reference implementation, my proof of concept, and I wanna do this with Pinocchio. Can't be so hard, I make it a bit bigger even. Okay, can't be so difficult, eh? So basically, here we have two instructions. I'm gonna just really have one instruction and make the difference that one time I don't take any input and one time I do take input. Even though we said this expected profit, well, we don't really need that because we might not want to do that ever. Maybe we do. So, okay, fine. Let's just add it as well, just because. So basically, if my input data length is 0, then we're taking the snapshot, and otherwise it's the check profit instruction. Should be fairly easy. If instruction data, oh man, Rust analyzer. Okay, fine, I open this in another. There you go, that's better. Just the length of this, which is also not the most efficient way to do it, because I'm not really interested in the entire length. But the compiler will manage to optimize that, I assume. If that thing is 0, and I hope the compiler somehow manages to optimize that, and if not, then whatever, those few compute units I can afford. It's not like I have huge instruction data. This is my take snapshot. I could do the else branch, or I do here the check profit. I don't like to have too many ifs, just coding style, so I would, return here. Okay, now as for accounts, what did we have in this program? We always had the trader who is signing and the snapshot account. And for that one thing, we also needed the system program because we initialized that account as well. Okay, so trader and snapshot. Since it's the same, I can take my accounts for both of the instructions. Trader account, I'm just gonna do this because I know where it lives. And then the next one. And if we fail here, then we fail here. Whatever. I'm not gonna do proper error handling. Screw that. I want to be efficient. So should we in this instruction already assume that the account has been created, or should I still do the creation? It's a design choice, but I think I'm gonna change it such that you'll need to call the system program yourself before you call this instruction. I'll need that set up because I want to teach you something else. I could do the CPI into the system program to create the account, but first we're gonna do the thing with you already created this account. So this account already exists, it has 8 bytes of data, and we are the owner, so our program is the owner. Let's work on those assumptions, and then I can just be like, snapshot account. Oh, why is it not working? Oh, because I said god damn, that's better. Okay, I will try borrow data mutably and unwrap. I could also just be more efficient and borrow data YOLO. Yeah, but that's unsafe, so I would need to make it an unsafe block. No, whatever, it's fine like this. I'll just fail if it doesn't unwrap. Again, hoping that the compiler will optimize those things away. And into the snapshot data, from byte 0 to byte 8, we just write the current Lamperts. Oh, wait, that's that stuff we do in here. Oops. So current Lamperts. Actually, because I need it both times, that I can do outside again. The current trader Lamperts, I'm gonna try borrow Lamperts, which is a reference of a U64. So I will just write the current Lamperts. Does that work? No. Oh yeah, because here I'm writing bytes and here I have a U64. So U64, 2 little endian bytes. This guy. And then this is not sized. Let's just copy from slice. Maybe that's easier. Current Lamperts, 2 little endian bytes. I don't need to go through the class if that is already a U64. And consider borrowing. Okay, there you go. How about that? Cannot mute, immute. Well, be mutable. There you go. I know how to write Rust. Of course I do. Again, working with Pinocchio is maybe a bit more complicated than working with Anchor because we need to do all of those things ourselves. And Anchor just lets us assign the U64 directly. It's more convenient, but less efficient. You want to be efficient. Or we have less control. I want control. Good. Is that all we do in the snapshot? We write that? I think so. And then we return okay. So that's fine. Good. Now checking the profit. Will I ever check the program ID? No, I will not. Checking the profit. will then be reading the previous lamperts from the snapshot account data that I could also already do here, because I will need that both times. But once I don't, take it back, because this time I don't need it mutable. This time it's fine if this is not mutable and I just try borrow data. I do a U64 from little endian bytes, snapshot data 0 to 8. How's that? Doesn't like it. Why not? Expected, found. Always the size stuff. There you go. Is that how I need to do it? Yeah. I could also do a check if the length is actually at least 8, like the snapshot data length, this one. But nah, if it crashes, and it will fail anyway. So whatever. I'm just trying to be efficient. Okay, so we have the previous lamperts and we have the current lamperts. So now we just check if the current lamperts are less than the previous lamperts. Then we will fail with... There, that's what I need. Custom 0. There you go. And why can I not import that? Can I import that? There you go. Import that. That's what I want. Okay. So why are you complaining here? We're comparing a ref with another ref. Let's check. Yeah, that's a ref. And the previous lamperts is a U64. Okay, so the current lamperts, can I just, there we go, just get into the inside of this ref? Deref it. Yo, let's go. I know what I'm doing. Of course I do. So if my current lamperts are smaller than the previous lamperts, I error. We still haven't implemented the thing with expected profit. Do we need that? Do we want that? I don't think so. I think I'm just gonna throw away that feature. It seems pretty useless, actually. So I'm also gonna optimize for functionality. Throw away functionality. We don't need that. Unless I need it, then I'm gonna add it again. But I don't think I will need it. I'm just gonna always succeed if I made a profit, so it's fine. So the difference will then just be I provide any instruction data and it will do the check profit. Only if I don't provide instruction data, it will take the snapshot. Should work. That's fine. That's logical, right? Of course it is. Oh, well, of course it is. What you say? That's not logical at all? I only meant well. Yeah, of course I did. What you say? That it's not gonna work? Well, let's try that. Let's try if we can build and deploy and run this thing. So, cargo, build SPF. We got warnings. What's the warnings? Oh, we have some import that we don't use. Yeah, sure, whatever, it's fine. But otherwise, can build, great. Okay, check key, I like it. Not like we don't have enough keys with check already. And you know what? I'm gonna copy. We have a bunch of keys that start with check. I take the check W. Gonna copy that to target, deploy, profit checker key pair. And then I Solana program deploy the target, deploy, profit checker. And this only takes 22 transactions and not as much Sol as an anchor program. So also in that regard, we optimized. Therefore, there is no IDL on chain, but do I need that for my profit checker? No, I don't. It's just going to be me using it anyway. So let's check if we have a win, a W. So I want to use my Pinocchio program now. It doesn't have an IDL, so I'll have to do all of the instructions myself, but that can't be so hard, because all I need is the correct program address. Let's do program address be the address of, where did we just deploy to? Here. And we have the program address and we need the accounts. That's true, we do need the accounts though. So the trader itself, address is the trader address and role is writable signer. And then the other one, I will need to have a snapshot account. Just gonna do a key pair signer for now, which is just writable. And the data, here we don't need data. If we don't have any data, then it's gonna be the snapshot instruction. And if we wanna do the check profit instruction, then we need to provide some data. And really, it doesn't really matter what data it is, as long as it has a length of at least 1. There you go. That should now almost be the same, except I didn't create this account. So I will need another instruction, get create account, which I will do directly with the system program. So pnpmi add Solana program system, and then Solana program system, a get create account instruction, which needs the new account, which is my snapshot account, the payer, I'm gonna let the trader pay, the Lamperts, and now here it gets interesting. Because my question is, could I do something like this? The program address is my program address and the space, 8 bytes. Could I just pay nothing for 8 bytes? Because I'm okay if the account is being thrown away again afterwards. Although, am I okay with that? Yeah, if it already has 0 Lamberts, I don't even need to remove the Lamberts, so it's fine. And that... No, wait. Before we go there, let's do it correctly as you would, you know, as you would with a RPC get minimum balance for rent exemption for an 8-byte account. That way it should work, right? We get enough rent on there for an 8-byte account and we just use 8 bytes. Then the account will still exist afterwards. So that's the regular way. Let's just test if our program works before we play around with rent. Do you think it will work? Or did you already find a mistake? Let's see. Let's just run it. Seems to work with success. We did a profitable trade and all of my checks give me success. Okay, let's look at that. Look, that's a nice account. Goosies. We created this account with minimum balance for rent exemption. My trader did still pay because that account was expensive and we didn't make that much profit in the trade. So overall, we're still negative, but the trade was positive. And if that was an unrecoverable account now, if I couldn't get the SOL back from this account, which as the trader I couldn't, in that case it would make sense to implement a minimum expected profit such that, you know, this doesn't happen because we lose more than just the transaction fee here. But if we can recover that, then it's still fine. However, the program doesn't allow it, so we cannot. I could implement it because I have control over the program, but whatever. Anyway, so we did make a loss, but the trade itself didn't make a loss. It just used a lot of compute, the same as it did in our transaction before. Here, that was our comparison. But the snapshot and the actual checking is now way more efficient with 71 and 77 compute units respectively. We threw out some features, obviously. We don't write messages anymore. But if you optimize for compute units, then that's pretty good. That's like from 10k to 70. That's 2 orders of magnitude. That's a good improvement. 10k to 140. Okay, 150, whatever. Still 2 orders of magnitude. Good. So our program seems to work. Does it really though? Let's check the negative case by not doing a profitable, but doing an unprofitable trade. Then there we go. The program fails my transaction and that's what it looks like. It errors. I just paid transaction fee. The account then also isn't created because also that is reverted because the check here, so the snapshot worked, but then the check gave me custom program error 00, which in our case means we didn't make enough profit. I mean, it's the only error I have. I could do another custom error, but I do 0. I could do 0x dead or whatever. Yep. Okay, so our program seems to work. If we quickly redeploy this, then we should get 0x dead. There you go. Okay, but that means my program works and it's more efficient now. Great, job done, an hour, done. Okay, cool. No. We want to keep optimizing because for now, we were still ignoring this entire system program instruction, which also takes compute, 150 if I'm not mistaken. Let's do a quick calculation. Why did I reserve that many compute units? Did it take fewer for the system program? That's weird. Anyway, total is that, so it's 95 something, and the market simulator in the unprofitable trade took that much minus this. Is 200, so it's 300. Yeah, so it's another 150 because minus 77 minus 71. Oops, it's 75 here because it fails earlier already. Yeah, it's 150. So this also takes 150 compute units, which I must not ignore. That now plays in there. Earlier we just had it in here, so we also need to account for that. So it's still 300 compute units, still better than the 10k, but you know, we still do this. I shouldn't ignore it. Okay, anyway, But speaking of the system program instruction, let's go back here. Let's go back to a profitable trade and say, hey, I want to kill the account later anyway. Can I just from the beginning tell you to not put any Lamperts on there? I mean, I can tell you, but will it work? And now we do a let's play a round of who's gonna be a millionaire. If I put 0 Lamperts here, will it A, already fail in the create account instruction? B, fail in the instruction where I use that account because the account doesn't exist, so it would then fail here? C, it will work? Or D, something completely different? Always have the something completely different as an option, because that's always an option. I don't know, I'm not smart enough. Make a guess, make a guess, make a guess. I love playing these games. I have no idea myself. Well, I have some idea. Do you want to know? Or do you want to keep thinking about it? If you want to keep thinking about it, pause the video, because I'm going to tell you what I think. I think that this is not going to work, because that account will be cleared after this top level instruction. I think if it's done like this, then already in here this account doesn't exist. Oh yeah, that's already using that account, so it would already fail here. That would be my B. However, if it was done as a CPI, then it would work. Although maybe the system program also just doesn't allow to create an account with 0 Lamperts. But I think it does. Let's see, let's just run it. So I would say it doesn't work because here this program will be like, that account doesn't exist. And really it will complain. If I were to guess the exact error, I would guess the program says trying to write to an account that it doesn't own. That's my guess for what the error is gonna be. So let's try. And success. Nice! So I was wrong. It's giving me success. And the post balance of this one is 0. Wow. That's amazing. I love this. Okay, let's check the transaction. Check this. That's so cool. Look, we did make a profit. An actual profit. Because we did not pay for this account even though... Wait, I'm too big, am I not? Hold on, let me go smaller. But yeah, we did only temporarily pay for this account. It ended up with 0 Sol nonetheless. The create account worked. I literally transferred 0 Lamperts there, but I allocated 8 bytes. And then I legit wrote to that account and later read from that account. Did I though? Let's check one of the previous transactions again. One of the previous ones that was successful, where we created the account and it persisted, this Goose's account. If we check that account, it has the then Lampert's amount written into the first 8 bytes. Okay. And it's still owned by that checker win1 program, my Pinocchio checker. But this transaction, that account obviously doesn't exist anymore. But has it existed at that point where it read and compared the Lamperts? Probably. Otherwise, it should have maybe compared, although maybe it read that, I don't know. So to really make sure that it did write in there, let's use the negative case where we do an unprofitable trade. Because this then should fail. Yeah, we did. Yo, check this. That account we could read in this transaction. Otherwise, we would not have ended up dead. That's cool, okay. Yeah, true. Then I misremember something. There was something else that is checked between the instructions. Or was it just between transactions and I misremember? Anyway, so it looks like within a transaction, the account keeps living even if it has 0 Lamperts. Only after the transaction will it get cleared. Yeah, that makes sense now that I say it like that. That's always how I imagined it to work. But I also thought that it might require the rent. No, it would be inefficient to check that between every instruction. So yeah, that's a transaction error. Let's say, because we want to keep learning, if I put on 1 Lampert, when is that gonna fail? A, at the system program instruction. B, at the next program instruction that tries to use it. C, it's not gonna fail at all. Or D, at the very end of the transaction. And the correct answer is, of course, yes, D, at the very end of the transaction, when the runtime is gonna kill me because I have insufficient funds for rent, right? First of all, I'm killing it first. But if I wouldn't kill it, if I were profitable, then it's giving me success. What? Wow, I'm wrong twice in a row. I'm starting to doubt that I know my shit. Oh no, it does. Yeah, there we go. Okay, it does. The simulation still comes back with success. Overall, the transaction still fails because insufficient funds for rent. There you go. Okay, so I wasn't wrong. Okay, good. I just read the logs wrong. Yeah. So this account that we created here, where we put one Lampert on, all of the instructions still work with success, but we're still being killed because that account with its 8 bytes needs at least 0.0009 something sol, and I had one Lampert, which is not enough. That's why it's killing me. Because since like almost forever now, we need to always be rent exempt, so we need to always have enough rent, or basically rent for 2 years. Also the 2 years, it's random anyway. Like, we need to pay for that rent, which is also the wrong word for it. But, we still call it rent because that's what we started with. Anyway, we don't have enough Lamberts in that account for that account to persist. Therefore, the runtime kills us. If it is 0 though, so if we have less Lamberts even, but they are exactly 0, then the runtime is like, okay, I'm fine with that. Sea level doesn't kill me because it can just delete the account. However, if there's one Lampert on there, it cannot just delete the account because it wouldn't know where to put that Lampert. That Lampert needs to move somewhere. And also, if there's Lamperts on there, then me as a developer, I expect the data to stay there. So sea level will never just destroy an account where there's Lamperts on there. If you take all the Lamperts off, then you're basically indirectly saying to sea level, hey, you're fine to kill that account now. So we don't need that in state anymore. We remove the Lamperts, thereby deleting the account. So if I let it delete the account after that transaction again, I just say 0. However, that makes me wonder. Because if I need to pay 0 Lamperts up front for an 8-byte account, can I also get a 10 megabyte account? Have you ever tried this? Because let me tell you, 10 megabyte accounts are expensive, like 60 sol or some shit, which I can't afford, at least not on mainnet. But if it's just temporary for one transaction, can I do 10 times 124 times 124? Do you think that would also work? Hey, no, let's just run it. I have no idea. I mean, let's just run it. I mean, looks successful. This is fun. See, that's how I like to spend my time, trying to figure out the boundaries of what's possible. I requested that much data, sure, and my programs worked. They didn't really use that data, but let's check. Solana rent for this amount would be 72 sol. If I were to want to persist that account, I would need to pay 72 sol. Holy shit. Obviously, I'm not gonna do that. But it's fun. It's kind of really fun because that basically gives me 10 megabytes of temporary I mean, in my program, I can make up storage and put stuff in storage, but it's also cross instructions. Like, I write it in this instruction and I can read it in this instruction and I get basically 10 megabytes for free. So temporary state. This is basically a data flash loan. That's how I think of it. I get data for free, like state. I can borrow 10 accounts with 10 megabytes for 0 Lamperts if I kill them in the same transaction. That's fun. That opens up some probably nice use/edge cases. I'm not even gonna suggest what you can do with that, but you'll be smart enough to figure stuff out. It's probably nothing like productive, hence I'm not saying it, but fun, could be fun. Could be, yeah, sure. Why would you temporarily write 10 megabytes? I don't know. Only if you do evil stuff. Maybe not. Maybe there's a use case for it. Who knows? But let's try if that actually, like, does it actually though? Wait, before that. One more thing before. If I were to request 11 megabytes, then it should fail, hopefully. I guess it would fail here. Yeah, because that is the maximum that we request. Is that 10 megabytes? Yeah, that's exactly what we requested. The max allowed is this, the 10 megabytes. And I tried to request 11. Okay, good. So that doesn't work. 10 megabytes is the maximum. Good. Now we also check that. Okay. Now, with those 10 megabytes though, can I like actually work with them? Could I, instead of go from 0 to there, let's set this as offset -8. The compiler will optimize that away, don't worry. And then I go offset to offset +8, and then the same down here, of course. Would that, if I rebuild and I redeploy, do you think that would then also actually work? Because that would then prove that I can actually use those 10 megabytes, which I think I can, because it's gonna be, like, if I say it's a 10 megabyte account, then I allocate that, although I'm not sure. It should be, but I'm not sure. Like, I'm not 100% on this. That's why I'm gonna just try it. And yes, it looks like that's successful. Wow. Obviously though, for really checking that it actually does the right thing, let's go unsuccessful though. Does it kill me now? No, because I have the exact same thing. Okay. Same is not enough to kill it. Here I go dead. Look at that. Wow. And I did redeploy, yeah. Wow. I basically get 10 megabytes for free. And if I get another account, I get another 10 megabytes for free. This is fun. Obviously just for within that one transaction, but I honestly didn't think that would work so easily. I thought that I would need to do that through a CPI. Like that I need to create the account with a CPI, then I can use it. Then I would also need to do the trading with CPI because otherwise I would lose the account again. But no, apparently I can just write to that account. What if I don't create the account though? Then obviously that should fail. Yeah, we panic because we can't write to that account. That makes sense. Okay, so I don't need to optimize this further. I mean, I could, but actually, I don't think it makes it more efficient if I would put the create account into a CPI from my program now. Because also the CPI will cost me compute. So doing the CPI costs me compute. And then executing the system program instruction also takes the 150. So I don't save anything if I were to do this as a CPI in here. So I'm gonna leave it out here. It's still the most efficient way to do it. Okay, cool, perfect. Let's leave it like that then. If I don't win anything from changing, why would I change? However, I can optimize this further. Look at that. Because currently, if we have profitable, or let's say it's just not profitable, it's just, at 0. Let's do that. What does that look like? So we don't win some, we don't lose some. The transaction gets success because I only fail it if we make an actual loss, not if we have 0. So that's why there's 0, 0, 0, 0. This is my 10 megabyte account that I throw away afterwards. And this is the bank where we don't win or lose anything from. So because we had a successful trade and an unsuccessful trade, and they even each other out. We can see that down here, yeah. So I still just pay the transaction fee. However, the transaction fee has become bigger than what we are used to from the previous video. Not because we use priority fees, but because we use 2 signers. And we pay the base fee per transaction signer, because the more SIG verify they need to do, that's what they price in with this, right? So we want to get rid of this second signer. I mean, we create an account that we throw away, we do it with a signer. This is inefficient. That we can still improve. And we're pro devs here, so let's do that. And how can we do that? Well, instead of using, a generated key pair signer that we then throw away anyway, might as well work with seeds, because I love working with seeds. That's precisely what the with seed is for. So we do the same thing, a create account with seed instruction now though. So it's the same, a get create account instruction, but it's a create account with seed instruction, which should basically take the same thing as this guy and a few more. So I assume I can just copy that over, except the new account is now just an address and not a key pair anymore. So let's throw away that. Let's make it an address. Snapshot account is an address of something, then that should work. And then it doesn't have Lampert. Oh yeah, this is so weird. Why do you call it amount here? That's one of the weird things. It calls it amount, not Lamperts. And then we need those additional things, the base, the seed, and the base account. And to know what those should be, let's first look at how I get the address for the account. That's with a get, no, what was that? Derived? No, that's not program derived. Find seed. I never know. Man, what was it called? I never remember that. Why is that so difficult to find out? In the Web3 chase it was also in pubkey, but here it is living as a function like the get program derived address, just that it's not that. But oh wait, let's go there. That's program derived address. There. Create address with seed. Sure. And that's also in PDA for whatever reason. Whatever. It doesn't matter. We found the right thing. So this thing, what do you take? You take the base address, the program address, and the seed. So the program address, that needs to be the one that we assign it to. So that will be then the owner. The base address, that's basically the signer. Like we need to provide a signer that then, only this signer can create that account. And the seed can be any string. So base address, let's take my trader. Why the hell not? Program address, let's take my program address. My program. I need to have that. And the seed, YOLO. Because who cares? YOLO. And so that gives me a promise for an address. So I have an address and then that should be fine. And then I just need to also provide the same things here. So I have the base, the seed is gonna be the same, YOLO. That's easy. And the base and the base account, that's always a bit confusing. What's what? The base, I think, is the trader, because that thing, no. Oh, I understand. So the base is just the address, like we provided here. So the base here really is the base address here. And then the base account, that guy, then is the transaction signer. And that is optional, because in case it's a PDA, then I don't need to put the signer here, I guess. Or what's the... What if I leave that out? Let's be curious about what happens if I don't provide the base account. The new account, that's this one, the base account, yeah. Okay. Let's just try this and see how it fails. It should fail. It does fail. It already fails address string length out of range. So it already doesn't like that. Maybe it's just a problem with Kodama thinking that it might not need that, when in this case it really needs that. So I need to provide the trader here. Otherwise it wouldn't even... So I need to provide the signer and the base. This should really be optional and take this address, but whatever. I have to provide it all. Here we go. And again, this is the same signer though as the transaction fee payer. So this is not an additional signature. It's still just one signature. So let's see if that would work. What's your guess? A, yes, or B, no? Expected base 58 encode address string of length, actual length 9. Wait, what? Where? When I try to encode what exactly? What has length 9? The trader? The snapshot address? Where are we failing here? That's a weird error that I can't explain right now. Cause undefined. Wait, was that the same thing that we saw earlier? Yeah, wait, that's still the same thing that we saw earlier. Hold on, we're still doing something not right. Hold my beer. Wait, forget about that trader. We're still failing somewhere else. Hold on. Console, log me what you get as the snapshot account. That sounds about right. That looks like an account, so that seems to work at least. And then, where do you get 9 bytes from? And what is complaining here? Oh wait, are we... Oh, I still have an issue here. Is that from one of the... Hold on. Because I changed it from the signer to just the address. Now I need to, of course, remove address here. Maybe that's where that came from. Yes, that's where that came from. Okay, interesting. But now even without providing the trader, I still didn't do that. And that worked, to my massive surprise. And look! We are just paying 5,000 Lamperts now, because we just have one signer. But we still create an account, well, pseudo create an account. We say we create an account, but we put 0 Lamperts there. We still use the account with 10 megabytes, but we don't really... This is fun. I enjoy this. This is ridiculous, but also fun. So I can use that 10 megabyte account in my entire transaction. And then if I'm done, it just gets auto-deleted. I don't need it anymore anyway. And I'm not even signing for it, so I don't even need to pay the base fee for it. Isn't that cool? So that's now pretty much the most optimized version of this that I could probably still optimize it a bit more, but that's as far as I can think. There might still be something that you can optimize here, but that seems already quite efficient. Like, we're doing this with seed, which I think this also only takes 150 compute units, right? So we are at, yeah, because we do more trading. Oh, there's compute units consumed and then there's transaction cost. Oh, that's new. Topic for another video. What the hell is this? But yeah, we're at 73, 79, and I guess that's still 150. So total was 1724 and the trading was 7. Anchor is just so inefficient. Yeah, so my profit checker just used 302 compute units. That's efficient. The trading is not. But that's usually what you expect, right? That the trading does take quite some compute because we're working with a lot of accounts. Here we're just simulating, but whatever, it's fine. Anyway, we're also still requesting way too much. I need to lower the amount that I request because that's just stupid. So I need to compute budget. Is that how you write it? I think so. Nice. Get, what do we have? Request tip. Set compute limit. That's what I want. And then I would set a price for priority, but let's just do that. And since I don't know how much the trading actually needs, I'm just gonna request 20k. Still better than what I did so far. Of course, that also costs me 150 compute, but therefore I don't request way too much. So now it looks like this. I requested 20k, I used 19k, well, I used 17.4. But then the transaction cost is 19k. I really wonder make sure you subscribe because I will make a video about that because I can't let that sit on me that I don't know what that is. But yeah, we did increase our priority even if we don't actually pay priority fee. Did you know that? It still increases your priority just by paying for base fee if you lower your reserved CUs, like the requested CUs. It used to be requested, now it's called reserved. It's a better name, yeah. Yeah, it's cool, but I like this with seed, YOLO, transfer nothing there and request that many bytes. This looks so hacky. This looks like something that an attacker would do for some exploit. You don't have it from me, even if you have it from me. Don't say that you have it from me. I'm not telling people that's possible. And okay, people could figure out themselves. But I mean, there could be interesting use cases for that. But yeah, you pay the rent for persisting state. And if you just, use it temporarily in one transaction, then you don't need to pay. That's fine, apparently. So I learned something here. This is actually fun. I would not have expected that, but it's possible to just say, hey, give me an account with 10 megabytes. I just need it for this transaction. And then you get 10 megabytes. Wow. So yeah, cool. We did learn about optimization. We did learn about rent, that you only need to pay it after everything. If you're done and you want to persist the state, then you gotta pay the rent. But not in the middle. The middle is fine. If you want to share some state between instructions of one transaction, you can basically request as much memory as you want. But you still need to do it through state, right? You still need to, if that instruction wants to talk with this instruction or this instruction, it needs to do so through accounts. It can't just use working memory. So you gotta go through accounts, but you don't need to actually pay for it if you don't need to persist it. Cool, good to know. Now we know. Okay, let's make one more successful trade, just because I can. Let's go. Program doesn't kill us. We only pay for one signature, the base fee, and we made 0.003 sol. Ending up here. Isn't that nice? We're in profit! Woo! Yeah, and with that, I think I can leave you. I showed you a few neat little tricks like this and all of this, just optimizing a program, writing it in Pinocchio instead of Anchor makes it way more efficient. And yeah, I would say we can call it a day here. I think this is good. Well done, I would say. Thank you for watching this video. I enjoyed it. Like, I learned something, and I always love it if I learn when I do those things. And I hope you learned something too, and that you enjoyed it as much as I did, and that you subscribe and give me a like. And and watch some more videos here. You don't need to, but I'm just enthusiastic about things. I love Solana development. It's fun exploring those little things. If you're curious about something, try it out. That's basically what I do. If you're curious about something else, try it out yourself. Like that's how you learn, right? Just play with it. On DevNet, where you don't accidentally spend 72 Sol on an account that you can't recover then. But yeah, it was fun. It was fun playing around with this. And I'm actually super surprised that it works. But it works! So yeah, cool. And with that, I shall see you in the next video. Until then, goodbye!